we're on.
Yes, we are online. Hello, everybody. My name is Tom Breza. I'm a host for CPP London. Today we have class 17, which is first of our 4-week object-oriented programming. So for those who took a course, you got fairly high score. You should be able to follow. If you're not, you can still stay. We're not kicking out anybody, but you might struggle to understand the material. The reason why we did the course is to basically make sure everybody is basically on board. Yes. What's the point telling somebody advanced stuff when they struggle with the less advanced stuff? But don't worry, it's not the end of the world. I'll explain in a second. So first of all, thanks so much for coming. And for those who are first time, I can see one or two people new. Our class is weekly, and you can come in here and learn with us, or you can join us online if you can for whatever reason. Join us. We stream to YouTube, and you can watch, but like if you want to watch, and you can watch obviously our back catalogue of the stuff. Very important, Tristan laptop unfortunately is dying, and because this is a free event and Tristan is spending lots of time, he's a very experienced developer, I'm trying to help to raise some money for him and buy the laptop. So if you're feeling like you want to contribute, please do. It's no pressure. I have a new batch of licenses we're using as a default IDE. Yes, we're using a Sea Lion. Why we're using Sea Lion? Well, one of the reasons, it works on all 3 operating systems that pretty much all our students are using. So it's Windows, Mac, and Linux. It's very easy to use. Got very nice highlight, the IntelliSense and so on. So, and we got for free. Yes, for our students, JetBrains gives us the license for I think 6 months. Yeah, so you don't pay anything for it, you got it for free, as long as you're coming to see us. So if you need a license, drop me an email, and on the email, in the subject, put Sea Lion license. Inside the body of the email, put your name, your surname, email address, and I will email you back the license. Another very nice thing, next year in February, there is a conference of our sister group, I would say. It's called C++ on C. Anybody hear of it? Okay. The conference is created by Phil Nash, and he's our community sponsor. So basically, we're helping each other. And Phil is one of the guys as well who is helping us to get those licenses, so it's a very big friend of us. So if you'd like to join the conference, it's located close to Dover, very nice place, and at the moment is advanced ticket sale, so you can get them for less money. So if you want like a not extremely expensive, fairly cheap conference, which is very close to London, that's the thing. Others, you can go to CPP, Pacific, and US, and so on, which are far expensive and not as good as this one.
The other thing is actually they're if you're on Twitter, they're actually doing a free ticket thing for people who promote
raffle.
Yeah, raffle for people who promote this on Twitter. So if that's your thing, the details are on the website. They want you to say something specific in your tweet that I can't remember. But anyway, if you do that,
I go to CPP on C because give you a reason why you want to go, and paste the link to them, and they will basically draw.
They'll put you in the hat to get a free ticket, which is.
And definitely I will win. I never win. So today we have a week 1 of object-oriented programming. And the way we want to do is basically it's a 4-week course. From September, the class will be split into 2 parts. I just need to get the dates from September from Skills Matters. So what we'll do, the Tuesday session, it's more like a lecture, so it will be less of the exercises, because we realize exercises are blocking us quite a lot. So on Thursdays, what we want to do is dedicate a time when people sit down and do the exercises. And one of the more experienced developers will try to be on all of these sessions and give you a hand. So this way we hope that you can first have some knowledge and then apply that in practice. The new course...
Will that be the same timing?
So, for example, if it's happening today, it's class happening on Tuesday, and we're talking about, I don't know, let's say vector or whatever, building a game. On, let's say, Thursday, you will have the chance to work on the examples from that class.
6:30 to 9.
That one, which I'm trying to summarize with Skills Matters. They will allow us to use one of the tables, yes, by the bar, the big tables. So people can sit down there, take their laptops and have fun. The new course, the new basic course, our idea was to start on the 4th of September to give like a, simple cut-out date, end of summer, and we get on. However, we, after talking internally and so on, we realized this is not realistic yet. So we have to push it a little bit further down. But the course will start on 18th September. So if you still wants to review, you're not feeling extremely comfortable, you're very welcome. Even if you are the more experienced person, you're very welcome to come along to these courses. Why? Because you can learn by helping others. So if you know some of the stuff and somebody sitting next to you is completely green, doesn't know, you can help him sit down and repeat this so many times. It will make the stuff clearer in your head, so obviously it will benefit you as well. Just a couple of fun stuff which might be of interest to you. We have at the moment over 300 subscribers on YouTube. It's in last month.
Hello everybody.
Huh?
Hello everybody.
Yeah, it went hundreds. I don't know why, but I think within less than a month we got 100 subscribers. So far we had 2,945 views of our videos. So they're getting popular. They're getting traction, which is very nice.
2,945.
2,955
more. I might just sit at home and watch the video 55 times.
So you have a hard pass. By next week there needs to be 3,000. So far we had 43 classes since we started. And we are doing this for almost 10 months. So soon we will have it 1 year under our belt. So that's pretty much all the updates. Obviously, please stick your name or write your name if it's not in the list, if you want to be included in our stats. And after class, obviously, we are going to pub. You're very welcome to go. Buy this guy a beer. Make sure he got enough Polska. What's the name of the beer?
Paulana.
Right. Anyway, stop wasting your time, and I'm passing it to Tristan.
All right. Yes, so this is the first session of 4 on object-oriented programming in C++. So, Ollie's arrived. Good evening. So, I'll talk a bit more about it in a minute, but object-oriented programming, you've probably heard of it. It's a sort of very popular programming style, I guess, paradigm, they like to say. And C++ has lots of facilities that let you implement that, and that's what these next 4 weeks are going to be about. So we've talked about C++ on C. Let's get this out of the way because we do like to hear from you. There's one possibly new chap tonight that I haven't seen before. So we have this on Slack. There's this CPP Lang channel. We have our own room in there. It's technically invitation only, but you just have to go to that website, pop your email address in, go through a captcha, and it'll send you an invitation to this highly exclusive club of thousands of members. So please do that because it's a good place to chat between sessions. Yes, so just to expand on what Tom was saying about the Tuesday and the Thursday thing. The way that these things tend to run on a Tuesday is that I'll chat for a bit. I'll say, okay, here's a little exercise that might take sort of, I don't know, 15, 20, 30 minutes sometimes. Which, it works okay. But the trouble is, it's a bit like, your piano teacher getting you to do scales. It's a useful thing for, teaching you a new key or whatever. But it doesn't really get you, it's not really good practice for playing whole pieces because, you need, if you want to play music, you have to practice playing music. So the idea behind the Thursday thing is it won't be any new material. In fact, there won't be any sort of talking at all. What it'll be is a bunch of people sitting around, working together or individually if you want to, on some exercises, perhaps from the textbook, just to give you a bit more experience of writing actual real programs, rather than just a little sort of 20-minute thing that I've set up with a list of do this, do this, do this. In fact, instead it'll be something a bit more realistic. We've done a couple of these in previous weeks. I mean, we did, really going back, we did a noughts and crosses game. We got you to write. So it'll be things like that. Things that, it might even spread over multiple weeks. We'll see how it works out. But yes, it's not replacing these. It's a bit extra for people who want to do it. We won't be in a classroom like this. As Tom says, it'll be out in the bar. Just very sort of informal social thing. That's the idea anyway. If nobody turns up, we might reconsider. But
what times was it?
Well, we don't know yet. We're having to confirm
It will
it.
be probably the similar times as the class here.
So yes, the other thing is we're trying to create a more sort of modularized approach to the way we're doing these things. So rather than just one long, ongoing, never-ending stream of lessons, we want to break it up into sort of modules of fixed, relatively short lengths. So this is the first one. This is going to be 4 weeks just on OOP concepts and how they apply to C++. In future, we'll probably do other little short 4-week blocks, maybe templates, maybe STL, maybe, those are just two off the top of my head. And we'll also intermix those with more basic materials because we get a lot of newcomers who obviously want to learn C++ and they find that we're 13 weeks into the course and they can't follow anything. So we'll probably do something along the lines of, 8 weeks of basic, 4 weeks of, slightly more advanced, maybe another 4-week block, another 8 weeks of basic. We're going to try and work it out, exactly what we're doing. So yes, as I say, this is the first session, this 4-week block, module if you like. So the idea is, much as we did with the basic material, we gave you lots of me talking, and then the last week we did some revision, and Ollie prepared a little assessment. We're going to do the same thing, except in miniature. So we're going to have 3 weeks of me talking, and then the last week's going to be revision assessment, so you can find out whether you've taken it all in. And we can find out if you've taken it all in and whether this new idea is working at all or whether we have to go back to the drawing board. The last thing to say is that this is very much an introduction. I mean, there are countless textbooks available that are this thick, all about object-oriented programming in C++. Can't possibly teach you everything about it in 4 weeks, or even 3 weeks, which is really what I've got. But hopefully it's enough to get you started. And if you're already familiar with something like Java or C# or Objective-C or one of these languages that is very object-oriented to begin with, then hopefully you'll cotton on very quickly. Oh, I forgot about that. Right. Okay. Yes, that's a good idea. Before I really get into it, yes.
Okay.
Now.
Right. All right. So some of you did the test last week, right?
So sorry. Yes. So for those who weren't here, last week was, I guess, the end of the last block, and we had one of these tests that Ollie prepared. It was multiple choice. or some of it was multiple choice, some of it was freeform. But anyway, we have all the results now, and Ollie's just going to go through on aggregate how everybody did, I guess.
Yes, precisely. Right, let's try and hook this up then quickly.
This probably won't work with the stream.
That's the thing. Yeah, what about the stream? Do you want me to stream it?
No. Actually, would you be able to open it on Tristan's laptop or not?
Yeah, you've got access. Let's do it on your laptop.
Okay, just give me a second, everybody.
Open the browser. Yeah. Did you accept the access? I think you should have got an email. TG.
Good question. I don't know.
Let's try. I'll go to docs.google.com/forms.
Sorry, guys, we didn't practice this bit.
So yeah, while he's doing that, yeah, we ended up getting a total of 17 responses. So that was a bunch of people, obviously, who were attending the lesson, and several actually who are online as well. I'll show you. There's very good insights. I'm going to go through the questions that sort of trip people up. Okay, just log into Gmail. But I thought it'd be interesting just to go through the stats. When we eventually get in.
Sorry, yeah, Wi-Fi's been slow.
Okay, is there a shared with me? Get rid of the forms bit. Just go to docs.
You do.
Okay. Did you get this in America?
The laptop,
Australia.
yes. Australia.
Right, let's fancy keyboard. Right, when this loads, come on.
Is it that?
Oh, that is it, yeah. Okay. Cool. Right, we're getting running.
I'll put it up on the big screen. You can do it over your shoulder.
Yeah, that's fine.
Almost there. If the Wi-Fi wants to work.
The fun of slow internet. Oh, here we go. Come on.
The Wi-Fi's usually pretty good here. It must be just. The thing is, there's a Bitcoin meeting down the hall, so that's the problem.
Yeah.
Everybody's busy.
I wonder how
Mining.
much money
They're all downloading the blockchain. Yeah.
I reckon that actually really might be what's happening. It's 13 gigabytes.
All right.
Ethereum.
Go ahead and you're doing a window capture or screen capture.
Those responses.
It's doing it slowly. Well, I'll try moving the window at least. Are you doing a window capture or screen capture though? Because if you're doing screen capture, okay, that should fine. Hey, there we go. Right, bring it up. Yes.
All right.
Right.
You might have to use the.
Oh yeah, of course.
That's the one.
If I can click and scroll, that would be nice. Right, it doesn't scroll, just use the mouse. Right, so this is pretty much the summary of responses. Yeah, that's not very interesting. Go away. So, out of the questions that we asked, you can see that actually the hardest one was just selecting all the options that are true. This one was actually multi-point, so you could still get partial points for it. And I believe the final question was quite a difficult one for you. Anyway, so let's just look through that. The questions, right. So this one everyone fortunately found quite easy. Only one person got that wrong, and he knows who he is because he answered that it was a strongly caffeinated language.
I agree with that.
It is when I did it.
It's not the developer in the language, but sure. Nobody got the second question wrong, so I'm glad that you all realised that all structs do have a destructor, whether you're right or not. Now this is the one we started to try and trip you up. So the majority of you still actually got it wrong. The reason this was false was because main is special and you don't have to explicitly return a number. It's the only function where you don't have to do that. and there was a clue given that this was a slightly tricky question, but nonetheless, slightly less than half of you actually got that right. Onto equals equals being a comparison operator. We asked you, just should tell us what the scope resolution operator is, and the vast majority of you said it was correctly : : one of you thought it was operator : , which obviously is not, it's not an overloadable operator, and one of you somehow thought it was not equals. The not equals, I don't know where that came from, but someone clearly was confused by that. Then we asked you obviously to just select everything that's true. So obviously T and is reference to T. Vast majority of you got that correct. And of course that T star represents a pointer to T star. You got that correct. Someone just didn't answer it at all. They didn't know. In terms of what was true about some code we pasted, so we had like A, then a scope, then B, and then C from B. The correct answer was that A lived longer than B, and B lived longer than C. And the vast majority of you also fortunately got that right, so it seems we're doing something right. Nobody said that it was in reverse, so that was good. A couple of you were confused and somehow thought that they all had the exact same lifetime, so they didn't. And then two of you, one person surprised me actually, but I won't say who that was, thought that inner curly braces were not valid, and they are of course completely valid. Then we just asked you to declare a double, which is called X, and set it to 5.4, and it should be const. So these are mostly all correct. So obviously const of X is 5.4 is right. This was also correct. The semicolon was missing actually, interestingly, from two of those two responses, but we allowed that. Again, same thing with. Is that because of a spacing or something? I don't know. Somehow Google treats that's different. Obviously that's perfect. It's got a semicolon. This was also valid. This obviously is the one that's not valid. We have one response. I don't know where they got that from. This of course is fine again. They just reordered it. I can't remember what was that. Double X equals 5.4. Close but no cigar. You forgot to put const. So read the questions carefully. And then in terms of select, what was this supposed to be? Why is it blank? Okay, I can hover over it. So a function cannot be called until it's been defined. Quite a few people thought that was correct, but it's not. You don't have to define it, you just have to declare it. Cannot be called until declared. Obviously most of you got that one right, which is one of the correct options. It's generally recommended to place a function definition in its header file. A few of you thought that was correct, obviously sadly it's not. If you put a function definition in a header file and you include it from multiple translation units, you will have a linker error, the program will not compile, you cause yourself problems, it's best not to do it. Obviously placing it in the CPP file, the translation unit, that is correct and true. Again, same number of people got that right. And the final one that was correct was that ODR stands for one definition rule. A few people, however, thought it stood for one declaration rule. Fewer still thought that somehow it stood for both of them. I'm not quite sure how that works, but they did. Then we asked you to write the signature for a copy constructor. There's of course a few ways to do it. Someone just didn't have a clue. We have one where they made something up, not valid. This one, again, not a copy constructor, that's just garbage. It's just meaningless, that's literally meaningless. This was close, but no cigar, sadly. It should have been const my class ref as the argument. Close, but just not there. This was not a copy constructor, that's just taking a copy of itself. It just takes itself by value, its own type by value. That was sort of approaching it, but they didn't give any type, so that's not valid C++. Obviously this is perfectly correct, const my class and other. Also const my class and. We didn't require you to name the variable, so that is just as correct as that. For this. Sorry? Oh, actually, yeah, sorry, I did say no variable name, but I allowed that to slide. I allowed that to slide because you don't have to. That one was allowed, even though you technically violated the question, which shows you knew it. Mainly in the context of how horrible the other mistakes were, we sort of said, okay, fine. Again, that's perfectly fine. It's the ideal answer. This one was given a body, which is actually technically even better. It didn't say, we just said write a signature, not a definition, but that's fine. This one, I don't know where someone thought a copy constructor would involve taking a string ref that was const, but they did. Obviously, that was wrong, sadly. Someone thought that taking an int ref would somehow be a copy. This one, I don't even know where that came from. Again, somehow they managed a typo at the end, but that's fine. And then that's not valid. Oh, sorry, that's over and above. They declared the entire struct as well.
It's quite a lot of
But it's correct.
that people wrote.
It is, yeah. I mean, some of these are like you didn't have to declare the whole struct, but it's fine. It's legal.
Everybody had a different idea.
Yeah. So now we get on to one that was not that tricky, hopefully, but we asked what are fundamental types in the language. So we had int, which somehow nobody considered to be a fundamental type, which of course it is. It's interesting.
Not fundamental.
Oh, sorry. Yeah, sorry, my bad. Sorry, I said not. Ignore that. Yeah. So the correct thing is nobody thought that int wasn't fundamental, so that's good. One person thought that char wasn't fundamental, but of course it is. Byte, on the other hand, everyone seemed to recognize. Almost everyone recognized that. It's not a fundamental type. It doesn't actually exist. Nobody mistook float or double. A couple of people thought that long wasn't. Of course it is. And void, again, is fundamental. You can't do anything with it. You can't make a void L value, but it is still fundamental. Stood string, of course, is a library type, so pretty much everyone recognized that. Someone thought that Boolean wasn't. That bool wasn't, which of course it is. But quite a few people did still realize that Boolean is not. That's Java. Handle, of course, is completely made up. Everybody caught that one. And null, most of you did, but some people were caught out by that. They thought that null wasn't. Null pointer, of course, is a fundamental value, but it's not that. Null pointer is not a type. So maybe that was why some people got caught out by null. And then in terms of discussing what was used to describe a function, which one was the correct answer? It was the copy assignment operator. So we had a few. That was not good enough, sadly. It's not just an assignment operator. That's what it's doing. It's not what it is. Someone answered a different question somehow. Copy assignment, close, but you can do copy assignment without an operator. That's an act of doing something. Still not. You need the word operator. Another fine one. That's an even better. That was an even better answer because it was a member function, but equal points. Copy constructor, sadly, no. You don't assign to an operator. Again, that's what it's doing. So those were close, but no cigar. So if you did say operator overload, you were sort of close. You had the right idea. And then for the above code that I'd written, the gist of the code was that you had an operator overload. It was the same piece of code as the previous question, and it didn't have a return statement. So obviously the operator overloading of assignment, you're supposed to return a reference to your own type. So at the end of it, you should have return star this. If you don't have any return statement in any function that's meant to return something apart from main, it's not valid code. It will compile, but it is undefined behavior. And slightly less than half actually got that correct. Quite a few of you thought it was just illegal and it wouldn't compile, but unfortunately, due to what we've inherited from C, you can compile it. It's just undefined what will happen. Some people thought it would compile and just run successfully. Strictly speaking, due to the code, in most cases that may well happen. In other cases, it may not. Once you have undefined behavior, who knows? All bets are off. It could work, it may not work. So the true answer was this. And obviously, nobody accidentally got the joke answer that it would only compile if you use Microsoft Visual C++ on a full moon at midnight. And then I just asked people to justify why they thought their answer was correct for a bonus point. There's just quite a few very confused ones. We had some people being really technical and were saying, oh, the code's not valid at all because you didn't have include statements. But one of the points I'd make is when we're sort of giving you code to look at, you can generally assume that includes are implicit, otherwise it's just going to make the test question a bit too long. But obviously we got ones they realise it's not returning. But there were some slightly weird ones in here obviously the ones that thought it was fine just said, "Oh yeah, it's okay. I didn't see that." And then again, someone said not returning star. This is a very precise answer, absolutely correct. I don't know where that came from. There's no issue with the default constructor. Maybe they thought that constructors return a value. Constructors do not return a value, as I'm sure you'll get into with OOP. Yeah, I think you mentioned it before as well, yeah. This one, everybody got it right. Someone just capitalized the word auto. Maybe they were using their phone. Still, that's fine. So given struct t with int x, write an equality comparison operator with a parameter called other. So some people got close. They did operator equals. They thought it was an assignment. Sadly, it wasn't. Someone decided that the equality comparison for t would be an int, but obviously it's not. You need to compare it to itself. And they had no return type. Then, of course, on the other hand, this is perfect, almost perfect. Bool operator equals const t and other. For bonus points, the truly correct one would be to make it a const accessible member. So there should be a const between these two pieces. But otherwise, it would work. So this passes. Then we've got someone who thought it was for a different piece of code, and they did write a correct one, so I gave them partial points. But they didn't read that it was for this and not for the earlier code. I don't know. Someone thought that meant adding, or they typoed. I don't know. Maybe they typoed. Sorry if you did. And yeah, I didn't actually. So surprisingly, nobody got the most correct version of having a const accessible member. But these were fine. These would get you. Well, not this one, but this would get you a part. So write a constructor for the struct t at the start of this section, so the big piece of code, which takes parameters for all three of its fields and uses a member initializer list to set them. And your argument should be in order, and you call them x, y, and z. So someone just didn't know. Someone wrote sort of getting there, but they didn't have any arguments for t, so this is not valid C++ at all. This, of course, completely correct. The name of the struct was t. It takes a const to string x, a const ref to a string that's called x, const ref to a vector that's called y, and a const long that's called z. And they initialize a from x, b from y, and c from z. Perfect. Someone wrote strict, I don't know what that was about. Someone went even further and they decided to make long, the last argument, a const ref as well. Again, perfectly legal. This was fine. They used parentheses rather than curly braces, but it's also perfectly legal, so that's a pass. Someone took them by copy. Less than ideal, but strictly speaking satisfies the question, so that's also working, and a pass. Same here, same thing, just less white space. Which one? No, I was pointing to that one, but yeah, so this one was wrong, sadly, because they didn't template vector. Well, would that work in C++ 17? No, it wouldn't deduce it, would it? No. So that was sadly not valid at all. And yeah, so there's a fair mixed bag, but a fair few people got it right. And now on to the final piece, which was surprising. I've obviously gone through the people's individual answers and toted them up. About 30% of you were quite confident and thought that you'd got most of the answers correct. Nobody said that actually some people did. They said, okay, don't know. So nobody thought they did perfectly, and nobody did do perfectly. The best we had was, I think, 1 or 2 answers wrong. But yeah, about just under a third of you obviously figured you'd got most of them correct. Over a third figured they got half correct, and about a minority of people thought they got the minority correct. And the surprising thing was that you guys all actually estimated yourselves really well. Those that said they got the majority right, all of them actually did get the majority of the questions right. The ones who figured they got around half, most of you were actually slightly above half, but you were essentially around half. And the ones that said they probably didn't do very well, honestly didn't do very well. So yeah, I think, I don't know what you guys think of the quiz format and how Google works. I mean, I've found the stats to be very useful. They've been a good way of sort of estimating, and I think that from this pie chart, you can see that I think we've done a pretty decent job so far of bringing you into the C++ world. But without further ado, I shall let. So go on.
That's pretty positive on the whole.
Yeah, I think so. I shall let Tristan
A lot of people
crack on
seem
with the
to
lesson.
have, I mean, even where they got some questions wrong, they still had very much the right idea, just maybe got the syntax a bit wrong. And perhaps if you did it in real life and you got a compiler error, you'd think, oh yeah, I need to add those brackets or whatever it might be. So yeah, I'm pretty positive about that on the whole. I hope you are as well. Right. What are we talking about again? Object-oriented programming, that was the one. Right, so once again, it's just going to be a sort of a 4-week block, just introducing the concepts and how we do these things in C++. So I will be assuming that knowledge from the previous block that we just finished. So I'll be assuming you know what a struct is, what constructors are, what member functions are, what member variables are, all of that sort of thing. Which, well, according to the test, most people had a pretty decent idea. So that's good. So, what is object-oriented programming? It's kind of a big topic, and it's actually surprisingly hard to define, or at least I think it is. But this is the best I can do. So it's a programming style, approach, paradigm, as they like to say. It's basically around the idea of objects. Everything's an object, and objects interact with one another. Okay, so there are various programming sort of paradigms. You know, you can have imperative programming, which is what C does, where you just have a list of instructions. It's functional programming, where you have these functions that don't have side effects, and you don't really write the instructions. You let the compiler work out how to translate just your equations essentially into a list of instructions. There's a variety of different approaches. And object-oriented programming, I don't know when it was invented. I think the 60s, but it really became popular in the 80s and 90s. And there are lots of languages that were really designed around OOP, Java being the most prominent example, C#, which came a bit later, Objective-C, which if you've done any Mac programming, probably done Objective-C, which has been replaced by Swift these days, which again has a lot of object-oriented programming influences. And these languages include C++. So C++ was originally, way back when it was first invented, called C with classes. It was intended to add object-oriented facilities to C. After that, during the 80s, actually, it got a ton more features in it. Now, people like to refer to it as a multi-paradigm language, of which one of those paradigms is OOP. So, why is this a good thing? This is the marketing. I mean, I don't know whether this is true, but people say it's particularly well suited to modelling sort of real-world situations, real-world objects and their relationships, and also that it people to a large extent find it easier to grasp if your classes in your program represent real objects. You know, you have a table class that represents a physical table. I don't mean like a table on a website. It's right in front of me. It's the first example came to mind. And it's also a good way of modularizing your software. So very, very, in the 80s, we started to write much larger programs. Computers had become more powerful, started to write much larger programs than had been possible in the 70s, when computers had sort of 4 bytes of RAM. Suddenly had these powerful mainframes and things. People started to write really big software, and they found that OOP was very useful for breaking their software down and allowing multiple teams to work on it, because it has a very strictly defined difference between the interface, an object's interface, and its implementation. And you can have one team that works on this object, and then another team that doesn't have to worry about how this object works. It just knows that it sees what its interface is, reads the documentation. And so OOP is quite a good way of modularizing your software. That's really why it became very popular. So a bit in the way of this, but object-oriented languages, which I'm including C++, they generally work along have very similar ideas. They're sometimes expressed with different syntax or with different terminology, but they'll have notions of classes, usually inheritance, and they'll provide ways of doing data abstraction and encapsulation. So these are sort of the traits that OO languages have. They're not necessary to write object-oriented code. I mean, you can do it in C, which has absolutely no built-in notion of any of these things. But typically languages that are designed to make it easier to write object-oriented programming have these kind of notions built into them. And that includes C++. So there you go. What is OOP in one slide? That's usually the first 3 chapters of a textbook. So there we go. Now I'm assuming these ideas aren't new. That to a lot of people will already have done some Java or C# or whatever, right? So this is not that bit was not C++ specific. So if you already know Java, all of the concepts that you're already familiar with apply here as well. So in OOP, we model the world as consisting of objects, essentially, or in strict OOP anyway. And these objects interact with one another. Okay, so this slide is really terminology, if you like. So we might have a cup object and a person that can drink from the cup. Right, it's about kind of, the idea is we model the real world in a sense. We don't necessarily have to be real world objects. We could have a class of shapes. For example, if you were writing a drawing program, might be a useful thing to have. We say an object is an instance of a particular class. So we might have a class cup. We might have multiple instances of cups. This is an instance of a cup. There's one there, there's one there, there's one there. But a class describes what a cup is, describes the properties of a cup, describes what a cup can do. In this case, hold liquid. So we say that classes define the state that an object has and the actions that those objects can perform. Now, again, this is sort of very general terminology that's, languages have specific ways of describing this. What they usually call the actions, they'll call them methods. The state might refer to as fields. This is a sort of generic way of putting it. So to give you a specific example, I told you I'm really bad at coming up with examples. Literally what was in front of my face while I was typing this. So imagine we have a desk lamp class. A class that represents a desk lamp, which can have 2 states, on or off. And then we have some action that this desk lamp can perform, which is a switch on, switch off, or perhaps it's just got one of those that you press it once. No, the switch doesn't necessarily have its own state. But a desk lamp class describes what a lamp is. The class describes what the lamp is, how it works, what it does. An individual instance of the class represents the physical lamp on your desk. You can have multiple identical lamps, right? Yeah? So again, most of you have been to these sessions before. Previously we were talking about structs and we were talking about instances, and you can probably relate those kind of things in your head. So a struct describes the type and its member variables and its member data. And then we have instances of structs. This is how we represent these classes, how we represent these things in C++. So in particular, we model the state of an object using member variables, class member variables, struct member variables. And in particular, member variables can be instances of other classes. So a car class might contain an engine and a steering wheel and a gearbox and all the other thousands of components that constitute a car. It's a process called composition in OOP terminology. We compose objects of smaller objects. And those individual objects have state and have actions that we can perform on them. Oh, just gave the example of a car. Apparently I gave a simpler example on the slides. So a bicycle, you can imagine. Bicycle, it's got a frame, handlebars, wheels. Might have two member variables of type wheel, for example. So composition models what we call a has-a relationship. So A has a B. A bicycle has wheels. So that's what when we're using composition, that's the sort of relationship between objects that we're modeling. Still make sense? I'm not getting it. Either this is all really basic or this is all really complicated. I can't tell which one it is, but I'm just going to carry on talking. So feel free to interrupt me if you like. So that's how we describe the state of an object. And you probably already guessed, we can model its actions using member functions. It's really the whole reason member functions were even added to C++. So again, we think about a bicycle. What actions can we perform on a bicycle? We can pedal, we can brake, we can steer. Might be other actions we can perform, like change the wheels or whatever, but for the most part, this is the interface that you want for a bicycle. So actions often modify the state of the object. So if we think about our bicycle class, when we pedal the bicycle, we're going to increase the object's speed. When we brake, we're going to decrease the speed. If we turn the handlebars, we're going to modify the direction that it's travelling in. But not all actions that we perform on it, or not all member functions, perhaps I should say, necessarily modify the state. We can actually just ask it. Ask the bicycle, what is your speed? It might be an action we can perform. How fast is this bicycle going? What direction is it steering in? That sort of thing. This is all good, is it? Yep. Okay. So one thing I'm not going to talk about today, I'm going to talk about next week, is inheritance. So if you've done OOP, object-oriented programming, before, you'll know that inheritance, in particular in C++, public inheritance, models an is-a relationship. So you can create a hierarchy of classes, right? We're going to talk more about that next week. So for this week, we're going to focus on composition, encapsulation, all those nice, nifty buzzwords that turn up when you're doing OOP. Just have a little example, for which I need to fire up C-line. So if you'll just give me a moment. Fingers crossed. Yay. Oh, that's massive, and I'm going to have to type this somewhat over my shoulder, but there we are. I'll manage. Where's my mouse gone? Yes. Because I still have to operate the... So, C-line, we're going to go and we're going to create a new CPP class, and we're going to call it Polygon. So I want you to imagine we're writing a drawing program, let's say, and we want people to be able to draw polygons on the screen. So we're going to come up with a polygon class, and we're going to think about what properties this polygon has, what actions we can perform on a polygon, that is, what member functions it might have. So one of the sort of, I guess, tricks, not really a trick, one of the fundamentals of object-oriented programming is about how you design your classes and how you design them to interact with each other. So this is really just a tiny little example of how you might sort of start to think about those factors, right? So again, just a little example. For the purposes of this, I'm just going to put everything in a header, just to save me flicking between two files in the IDE. In real life, of course, you would put your code implementation in the implementation file. But for now, we'll just do header only, and hey, there we go. Oh, go away. Can I finish? Yep, so you see C-Line has created this new class with the keyword class. I'm just going to change this to struct, and you'll find out in about 10 minutes why that is. But if you're curious, it's just to make everything public for now. Now let's think about a polygon. Polygon it's a set of points, right? A set of points on the plane. So what's the minimum number? Or rather, let me put it a different way. Yeah, a polygon consists of a set of points on the plane, right? So a polygon's state, its internal state, we can just record it as a list of points. Does that make sense? So we'll go ahead and we'll create a struct point. And then in our polygon, points. And then, fingers crossed, I do that, and yay, it's imported standard vector. It's quite, C-Line's pretty good like that. So we're gonna have our internal state is a list of points. So we're just going to have a vector of points. We've called it points. I need to put a semicolon there. And these open and close braces, we don't really need it. It's just a habit saying if I don't initialize it in a constructor, just default construct it. But for vector, it's not really necessary. So that's the state. But let's think for a minute. Sorry.
Why not using the struct we have device reflects the line with the start and end points, and using several vector of lines?
That would be another way of doing it. Absolutely, yeah. I just wanted to. Yeah. So if you had a line class, for example, in this program that we've sort of done before for many of our examples. The trouble is that with that, the polygon doesn't consist of individual lines. If you think of a line as being 2 points, well, a polygon goes from that point to that point to that point. And if you just save the lines, you'd be repeating all of the internal points, right? But let's think about some of the things we want users to be able to do with our polygon. Right? Actions. So we probably want them to be able to create a polygon. That seems like a good idea, otherwise it's going to be a bit useless. But if you think about it, we need at least 3 points to form a polygon. Otherwise, all we've got is a line or a dot. Right? If it's going to be a proper polygon, triangle, you need to have 3 points. And actually, all 3 points need to be different as well, but we won't worry about that for now. We probably want users of our drawing program to be able to add a point. Maybe get the number of points. What else could we do? We could get the area. We set the color of the polygon. So we're starting to think about what the properties or what the interface of our polygon class should be. We've got a basic representation as just a set of points. But now we're thinking about the interface of the class. So it's always a good idea when you're doing this sort of thing is to first sit down and before you even touch a computer, right, work out what you want your class to represent and what your public interface should be. Because you'll normally find if you do that, your data representation, that is your member variables, that will sort of follow naturally. So think about the interface first. It's kind of what I'm trying to get across. But here we've thought about the things you can do to a polygon. None of this is specific to C++. You could do this in any language, right? Any language that has, maybe not that esoteric one with a naughty name, but any reasonable programming language. So we'll start to think about how we could do these things in C++. How do we go about creating a polygon, letting users create a polygon that has at least 3 points? How would we model, how would we take this sort of abstract idea of the interface of our object and do it in C++? You need to ask for the points. Well, first of all, how do we create an instance of a class in C++? With a constructor. Of course it's with a constructor. Thank you to nobody who said that. But let's write a constructor. So we need at least 3 points. So let's just call them A, B, and C. And then all we do is pop each one into our internal points vector. Yes, but that's well, you could, but it's a lot of typing. It actually, in this case, doesn't matter because 2 floats are going to be 64 bits, which is going to be the same as a, yeah, it's not going to save you, it's not going to be any more efficient to use a reference, but you're right that in general, for bigger, more complex classes, in particular for polymorphic classes, you'd want to take them by reference. So yes, that's a good observation. So Now let's think about adding a point. How would we represent this action in C++? An operator overload. That would be one way to do it. I think it'd be more sensible to just, initially at least, have a member function. So we'd have a member function that we'd probably just call add point. Now, we could do an operator plus equals. The point is, I guess the idea is it necessarily obvious to users that if you do polygon plus equals point, that you get that adds a new point to the polygon? Maybe it is, maybe it isn't. I think in this case, for simplicity, we probably just want a member function called add point. Now this member function, this action doesn't need to return any information to the user. So the return type is void. But we do need to know which point they want to add. And all we'll do is just pop that into the back of our vector, push that into the back of our vector. Getting the number of points. So how would we go about doing that? How would we represent that action in C++?
Let's return the length of the vector.
Return the length of the vector, or its size. So we'll be lazy because I don't want to write standard vector size type. I'll just call it get num points.
It's probably even better to not be specific here, right? Because you might not know what the exact type of the size is. Just rely on
Yes, the only problem with this is that if we were writing this sort of properly, if we were putting our implementation in the header and we were putting our interface in the header and the implementation in the source file, you can't use auto for that because when another file is just looking at the signature of this function, it doesn't know the return type. The compiler needs to be able to see the body of this function in order to work out what the return type is. So what we probably actually want is this type size t, which is an alias that's built into the standard library that just represents the size of a collection. But this is nice and easy. We can just return the size of the vector. So is this good? Is this finished?
Pass the points.
This is a member function, so it automatically has access to our member variable points. So if you remember I was saying before, we could explicitly do that if we wanted to, but it wouldn't really help us. This get num points is just an observer. We're not modifying our state in any way. It's just reporting part of the state. Exactly. So it's good practice to make this member function const.
Const accessible.
Const accessible. Yes, absolutely.
Everyone clear on what const accessible means?
that means no.
Means no.
Go on.
So go on.
It doesn't modify anything of the member variables.
Well, it doesn't modify anything anyway, but specifically const accessible.
Means you can call it.
Yeah. So more. What's the verbosely bad? if I want an instance of a polygon, right, I'll declare like polygon P, polygon X, whatever, right? So it gives me an instance of the kind. Maybe somebody wants to use that polygon, but they don't want to modify it, so they'll take a const polygon, so a const polygon X. Well, now that my instance of polygon is const, I can't use add point because that's non-const. I obviously can't call the constructor because it's already constructed, but I might want to read how many the number of points that it's storing. And if that const at the end isn't there, I can't call it. I can have a const instance, but now it's effectively useless because none of the functions on the class, on the struct, are declared as being const accessible. By that being declared const accessible, it means that I can have a const instance and I'm allowed to call that function. I'm not allowed to call add point, but I am allowed to call get number.
So we had a couple more member functions. Get the area of the polygon. What do we think the signature of the get area function should be?
Return float.
Yep.
Also const.
Also const, absolutely. Because just getting the area, we're just observing the object, we're not modifying it. So we declare the member function as const. I'm not going to try implementing this because if you don't know, calculating the area of an arbitrary polygon is actually quite complicated. So we'll just leave this one unimplemented for now.
I'm wondering about the case where you, for example, have no points, so 1 point or 2 points. So would you return 0 for those, or
Well,
for an exception or something?
if you look, our constructor, we only have one constructor, and it takes 3 points. So as long as this constructor doesn't fail, which can only happen if we run out of memory, so that's not actually really gonna happen in real life. If we've got a properly constructed polygon, it will always have a minimum of 3 points. So we can always calculate that area. If we add more points, we start getting into problems with self-intersecting polygons. It's actually quite a complicated problem, but in principle, at least, we can always calculate the area because we know from our guarantee in this constructor, the invariant of the class is that we always have at least 3 points. So if you like, the job of a constructor is to establish invariants. And one of the invariants of our polygon class is that it has at least 3 points. So we want to be able to set the color of the polygon. Well, we don't have any way of storing the color because at the moment a color is not part of our object's state. So let's just go ahead and event this enumeration color, red, green, blue. This is just one way of representing color. We might represent it as a struct with RGB values in, for example. In this case, I'm just...
What does the class do in this unit?
It means it's what's called a strongly typed, scoped enumeration. It's a new feature in C++ 11. So if you're familiar with C or C++ enums, it's exactly the same kind of concept. It's just that it's a little bit safer to use because the enumeration members, so red, green, and blue, those names are now private to this scope. So we need to say color : red. We can't just say red.
So it's got nothing to do with polygon. It's just you have to use color for red.
Yes, exactly. Yeah. So We have a new member function, set color. It's never used, of course, but we now have a problem because we need to introduce some new state to our object to hold this color. So all we'll do for that is we'll add a new member function called color, and maybe we'll default it to red. And all we'll do in our member function is set our internal color to whatever the new one is, to C. So the reason I put this last one in is to demonstrate that thinking about your interface will lead you to thinking about what your internal state, how you should represent that. Right, so design your classes thinking about the interface first. Don't think, oh, okay, a polygon's just a list of points, and just sort of throw that out. If you want an object-orientated approach, you think about the interface. What does our polygon class represent? What do we want users to be able to do with it? And that will lead you, in most cases, to what its representation should be. But there's an even more important point to this. Is if we have these actions, these member functions, in which I'm including the constructor, none of these things rely on the fact that we've used a vector as our internal representation. If I change this to a standard list, other than the fact I haven't included list, to the users of class polygon, there is going to be no difference. Well, they might notice it's got a bit slower. But other than that, it's going to work exactly the same, right? So our internal state, the way we've represented it, is not visible to the users of our class. And more than that, we can change our internal representation. We can change the way we hold our state without affecting our public interface. And that's sort of a key notion of OOP. It's this separation of interface from private implementation. Really sort of almost the critical idea behind it. And again, we've stored our color using this enumeration. We could perhaps we want to store it as 3 RGB values. If that makes our drawing more efficient, which it might do, I don't know. I haven't written the drawing part yet. That's what we've got. Almost 8. Okay, so this is just a little example, the idea behind it, sort of show you a way that you can start thinking about designing classes in terms of objects, interfaces, and later their implementation. Because we've, mostly in this class, we've gone into sort of really technical details. This is how C++ works. You know, this is what a constructor is, this is what it does. Now we're starting to think at a slightly higher level. Right? Think about the design of our software. So, we're going to go on to talk about encapsulation in a minute, but are there any questions from that? I don't know if anybody's online there, Tom.
Sorry. Question is on that note.
Nope. Okay. So let's go on to talk about encapsulation. So this is what I was getting at with the last example, is that we don't want external actions, that is, functions from other classes, global functions, non-member functions, that is, to directly read or modify the state of an object. What we want is that all interactions with our object state happen via its member functions. Because this gives us the freedom to change the way we represent our state without having to change every single user of this class. That's what I was talking about with modularizing software. If you've got thousands, tens of thousands of classes, you don't want one little change to mean you've got to go and change 10,000 other files. That would be a terrible way to write software. So the way we do this is to keep our implementation private, to keep the way we represent the object state private, and have a public interface which other classes can call our methods, can call our actions. So in object-oriented terms, this is known as encapsulation. Preventing other classes from accessing things in our class that should be private. And C++ has built into it a way to actually enforce this in code. This is known as member access. So again, if you're familiar with Java or C#, you'll be familiar with the idea of member access. There are 3 levels in C++. We have public, private, and protected. And all of our class members, that's the member variables, the member data, member types, which we haven't talked about yet, they all fit into one of these 3 levels of access. So as I say, these member access levels, they provide encapsulation. They control how and when an object's value, that is its state, when that can change. And way back when, a couple of months ago now, when I first introduced the struct keyword, I mentioned that structs and classes were virtually synonymous in C++, and lots of people harangued me and wanted to know a lot about classes, because classes are sexy and exciting and structs are C and boring. But the fact is they are almost exactly the same. There are only 2 differences, and one of them is that in a struct, everything is public by default, and in a class, everything is private by default. But it's not many, or not many, some languages have quite a semantic difference between struct and class. So for example, C# and D and Swift, structs and classes work quite differently. But in C++, they're pretty much exactly the same thing. Well, they are exactly the same thing. The only difference is in their defaults. Let's talk about public member access, shall we? Things that are public are accessible to the whole of the rest of the world. If you have public member functions, any other classes, any other class member functions, any free functions can call your public member functions. And we use the keyword public to signify this. So within your class definition, you put the keyword public followed by a colon, and everything that follows until the next access specifier is public. So to give you a little example, well, literally example. We've got a class called example. We use the keyword public followed by a colon, and this says that everything that follows it, in this case a public member function and a public member variable, these are all public things. So this is a class, so if I didn't include that, All this would be private. If I'd written struct instead of class there, so it's a good question. If I'd written struct instead of class there, what would the difference be? What would change?
It would now be private. Public, sorry.
Exactly the same.
Spot on. If I'd written struct instead of class here, there would be no difference whatsoever. Right? A struct defaults to public access, but here I'm making everything public anyway. I'm explicitly setting things to public. So I could change the word class into struct and it would be exactly the same. So as I said, public members have no access restrictions whatsoever. Other functions and classes can call our public member functions. And other functions and classes can read from and write to our public member variables. Now, what I was saying before, just a minute ago, is that we want to keep our state private. We don't want other classes to be able to modify our member variables, which probably gives you an idea that in general, in an OOP design, having public member variables is not a great idea. Right? In general, you want a set of public member functions, but you want to keep your member data, that is your member variables, private.
Why?
Sorry?
Why?
Why?
You don't want
I know
anyone
why.
messing up with your privacy.
Well, as I was saying, it's because it allows us the freedom to change our implementation without having to change hundreds, perhaps thousands of other callers of our class who have been relying on the fact that we use standard vector or standard list that we later want to change to a standard vector, for example.
You have a single source of authority. You can look in one file. You don't let anyone touch the private stuff. You only have functions that give, say, read-only access. And you can always just rationalize about one single file in the source code, ideally, to understand what's going on.
So the public members of a class define its public interface. Right, so it defines the actions that this object, in the sort of broad OO terms, define the actions that this object can perform. So next we have private, and if you couldn't guess, we use the word private to signify the things that in our class that should be not accessible to the entire world. So we write this just as we did before, except this time I put the word private and a colon. And this signifies that everything that follows is private until we hit the next access specifier. So in this case, slightly different question to last time. If I didn't write this, if I just deleted private, deleted this line, what would happen? What's the difference?
Nothing.
Again, nothing, because classes default to private access, right? So if I didn't write that, these things would still be private. And again, because I'm being explicit about the access, if I change class into struct, no change whatsoever. If you're explicit about your member access, struct and class make no difference. So when we mark our member functions, member variables as private, it means we can only access them. That is, we can only read from and write to the member variables. We can only call our private member functions from within member functions of that same class. Other functions and classes, external objects, may not call those functions, may not access that data. So this is a way that is built into the language of ensuring that idea of encapsulation, of ensuring that we know nobody is going to be relying on our private representation of our state. It gives us the freedom to change the representation of our state without messing up everybody else. So yes, other functions and classes may not read or write to private member variables. So public and private are by far the most useful of the three access levels. There is a third, and that's called protected member access. I'm sure you can guess by now. You write this with the keyword protected, followed by a colon, and everything that follows until the next access specifier is then protected. What does protected mean? Protected means that we can only access those members either via our own class, so like private, or from derived classes. So when we talk about inheritance next week, we're going to talk a lot more. In fact, it's going to be all about derived classes and how that works. So protected members are the interface that we present to our derived classes, as well as public, because public's available to everybody, including things that inherit from us. Protected is only available to classes that inherit from us. The rest of the world cannot access our protected members. So, again, just keep repeating myself, but if you're familiar with Java and C#, D even, these notions are pretty much exactly the same. Public, private, protected. In fact, they took them from C++. Right, so this should hopefully not be too weird for you. The only difference is, instead of writing them in front of every member, you just write it once in the class, and everything that follows is public. There is one more notion that is, I guess, a bit more unique to C++, slightly a bit more unusual. And that's the idea of friends. So does anybody know, in C++ terms, what friends are?
Useful access to one other class, or function, to other private stuff.
Exactly. A class can allow other classes, other class types, and other free functions, it can declare them to be friends. And those friends have access to all of the private and protected members of that class. So friends are a way of sort of puncturing a hole in this idea of encapsulation. Because normally it would only be your own member variables, your own member functions that have access to your private members. But declaring something a friend is a way of saying, okay, this other class's member variables also have access to my private members, so to speak. And you can do this, it's even more useful, in fact, with free functions. Free functions is sort of funny notion. It doesn't really fit into a strict OO terms. Java doesn't have a notion of free functions, nor does C#. But in C++, we have these free functions, and sometimes we want them to be able to access private members of our class. So a very common way to do this, for example, is with the OStream operator. Very often, just for debugging purposes, we want to be able to print our internal state. And if you remember from several weeks ago, we have to write an OStream operator overload as a free function. So in that case, we would usually declare it to be a friend of our class. So just to give you an example of what this syntax looks like. Declared this function called other function. Doesn't matter what it does. I've also, you might not have seen this before, this is a forward declaration of a class. So it just We can do this, the word struct as well, of course. But this is just saying there exists some class called other class. I haven't told you what it is yet. I haven't told you what its members are or anything. But just, hey compiler, when you see this name, this represents a class. So it's not always... Forward declarations of functions are very, very useful. Forward declarations of classes are less useful and don't come up as often, but I don't think we've seen them in the course before. So that's what it looks like. It's, as with a function, you just write the signature with no body. With a class, you just write the class name followed by a semicolon. So then we have our usual class example. And now I've said friend, void other function. So I've declared that this function with this signature, void other function, taking no arguments, is a friend of mine. That is, from within the body of other function, would probably have been a better example if other function took an argument of type example, but never mind. The body of other function may access private members of an example instance. And I can also declare an entire class to be a friend. I can either do it like this, or I can put the keyword if class in there as well if I wanted to. I could say friend class, other class. And this means that all of other classes' member functions, which we haven't declared yet, but we assume it has some, all of other classes' member functions have access to our private data. So like I say, the friend declaration is something that should, I guess, be rarely used. It's a way of puncturing a hole in the encapsulation. Or another way of looking at it is that friend functions in particular are part of your public interface because they have the power to modify the internal state of your object or read the internal state, just like your own member functions. So friend functions, if you want to think about it, are a different way of writing something that belongs in your public interface. So, friend functions, well, relatively common, they turn up. Friend classes are actually pretty rare. I can't think of many instances where I've had to declare an entire class as a friend, but it does happen. So yes, just to reiterate what I was saying, if we grant friendship to a function, it means that the body of that function can access all the private and protected members without any restrictions. And granting friendship to another class means that all of that class's member functions can access private and protected members without restriction. And just to reiterate this again, probably the most common use of a friend function is to allow streaming, output operator streaming, because it's really handy for debugging to be able to just print out to the console what the internal state of your object is. And because the vagaries of the language, we need to do this as a free function, we can't do it as a member function, we'll often declare that operator overload to be a friend of our class. And we've whipped through that, which is excellent. So we have quite a bit of time to have an exercise, if you'd like to. If you go to this URL, there is a Git repo that you can check out. It's got a little exercise in there. Well, you'll see it. There's a student class or a struct with everything public, and I'd like you to change it to a more object-orientated design, increase its encapsulation, using these lovely member access specifiers. So hopefully this URL will work. I know we had some problems with GitHub Classroom when we tried to use it before. But if it doesn't work, then let me know. It's worked for one person at least. So.
Just climb it.
Yeah, you should be able to. Yeah, I think there's a button to like check that out.
It's to make it
For private GitHub. Oh, so you don't just git clone that URL. You have to go to that on the website.
I've made it, so I'm just going to copy the URL.
Yep, perfect. And that'll give you your own private copy of the sort of starter code that you can modify in any way you like. Check it into your own GitHub.
They're working on
I thought that's what you were doing, but you weren't.
I'm all out.
Oh yeah, sorry. Yeah, there's an error in the README. It should say example of HPP, not student HPP.
You fix it.
If you,
Although people,
no, people have cloned it already.
you've already cloned it.
Oops.
I think we should message GitHub about it. Like, give us a way to amend repos.
Well, no, it's like force pushing to everyone else's repo. If they've added some commits.
No, you could amend one. You wouldn't amend it if you had a new commit, so then they just grab that.
Sorry?
I did show you right.
I'll go on then. Got half an hour.
Anybody needs any help, just holler. I'm here to help. This one's I've handed him the beer. That one. That was right the first time.
Has everyone cloned the repository and got started with the code?
I'm trying to sign up to GitHub.
Oh, sorry.
No, I'm sort of almost there, but I don't know where. I think I've tried before, so I've got that now.
That's quite a tough time doing the assignment on the phone.
No, I realise that. I know. I thought the meeting was tomorrow, and it popped up, and now I was somewhere else. So.
It's nice of you to come on.
Yeah. But I don't know what number of. I don't know which is running this thing.
Okay, so this is the first time.
Yeah, for me.
So,
Yeah, because I didn't realise you were running them. Sorry.
No, it's fine. So what we're doing is we're doing a little sort of 4-week block on object-oriented programming.
Yeah.
So we're sort of assuming some basic knowledge of C++ already for this block. So are you already familiar with it or completely beginner?
No, I mean, I am a beginner, but I've been doing Linux and C, and sort of trying to get down to C++.
Right.
I haven't quite got down yet. And I'm bored with JavaScript. But then, saying that, Python hasn't been so straightforward, and I don't know why.
Okay.
Because a lot of people do using Python, and I thought, oh yeah, I'll do that. Because it's obviously this is the crux of the matter, I understand. You just achieve a lot more. Well, it depends what you're doing.
Yeah.
Because it's compiling a few blocks.
Yeah, exactly. Yeah, Python. I mean, it's a
my-
teaching language. It is.
yeah.
I mean, there's no getting around it. It is easier.
But because of the physics, I'm doing physics.
Okay.
It's like that's why I thought I should try and get more of these students.
So actually, I don't know if you were here at the start. It's September the 18th.
Right.
We're so it's 4 weeks from now. September the 18th. We're starting again from the beginning.
Oh, maybe I should do that then.
So it sounds like that would be a
Yeah.
good sort of
No,
stepping in point.
Sure. Okay, put that down. Yeah. I've got a child as well, so it's just.
Yeah. Do you work on them?
It's an old story. I won't go into it now.
Okay.
So I was working as an engineer, but I'm not at the moment, so yes, big complicated.
Thank you very much for coming on.
Is this you claim?
Yeah. No, I just sort of noticed it, but I didn't notice it.
Yeah, it's example. It's just a typo.
It's funny, we occasionally the website Skills Matter, they occasionally they send out these weekly emails with sort of here's what's on. And occasionally we get featured and then we get some not many people coming on. It's
What time do you finish then? Is it sort of 9?
9, so yeah.
Is it like 9 now?
It's hard.
Oh, right, okay. Right, so what was the date? Just going to put the time.
18th of September.
Okay, brilliant. Okay.
So it's 6:30 till 9. It's when we run.
And it's 4-week blocks.
The introductory one will probably be an 8-week block.
Right, okay.
So that's the plan.
And when you say basics, I mean, what are the expectations?
I mean, to be honest, most people come with some programming experience
Yeah.
already. We have had some absolute beginners who have never written a line of code before in their life, and it's harder. I mean, there's no getting around it. If you're trying to sort of learn what programming is and learn C++ at the same time, there's no getting around it. It's more difficult. But if you've got some programming experience before, I think that's the situation most of the.
So I get all my I learned literally through gaming.
Oh really?
Basically, yeah, because the mathematics is the way that it's it's done quite well.
Yeah.
And it's accessible, and it's fun, and it's all physics and vectors, and so that's the pitch that I'm coming in from.
So
and then my background is hydrology, but that's just it's just basics. So I mean,
Another person who's suffered from the workforce. Me too.
So I'm just bored with JavaScript. So
Yeah. Well, that's understandable. So we
I just people seem to actually do their websites for them. That got a bit boring as well. So I just
So we start from a sort of low level. What are types, what are functions?
yeah.
How do you write these things? How do you declare variables? What is a variable? And then sort of progress from there really. So again, if you're already familiar with JavaScript, you already know what functions are, you already know what variables are. It's about sort of getting familiar with how you write these things in C++.
Yeah, that's what you said.
Every variable has a type, which you don't explicitly write in JavaScript or Python. So it's, I think, if you're already familiar enough with JavaScript to begin with,
Yeah, but that could be just my skill of understanding and
It is an
because it's quite powerful. But the other thing that's quite interesting is that a couple of people who work in Java they just feel that you need to know Java before you understand C++. What do you got time?
I've never written a Java program in my life.
Oh, right. I think it's just in the higher end part gets a bit more complicated.
I would disagree with that in general. Don't learn Java before you learn C++.
Yeah, I'm just thinking I'm never going to use it really.
And it's not so much just about not using it. The style of Java results in people writing absolute garbage C++. That's the real problem. Okay, I'm digressing here, but it's definitely not a language that you should take on after a language like C++. The biggest reason is new. That's the thing that peeves me so badly. People think that C++ is Java. The language kind of corrupts you in a way. When you come to C++, it's definitely not one of those. I think one of the principles that is worth learning first is object-oriented programming. That's sort of valuable. But do it in pick some scripty language where the paradigm sort of keeps you fairly safe. Python can, Ruby has it.
What's that say?
Ruby.
Ruby's not a bad one in terms of the sort of general object-oriented concept. No, not Rust. It's not really going to help you. You've got a weird syntax. Or if you're coming from C, then you kind of only just have to do a paradigm rather than a syntax. No, definitely not Java. Anything with Java.
Not a Java fan.
No, it's not that I'm not a fan. It's that the problem with it is that Java is garbage collector. So you
It's
create.
graphics, it depends what you're doing, doesn't it?
It does. I know Java. I find Java. It's just the
But
problem
I thought
is
Java was from C++.
it's inspired. It's absolutely inspired by C++.
Yeah.
The problem is it's a garbage collected language. If you learn Java and you're a language expert and you understand the whole garbage collected paradigm, then yeah, fine. You know what? Great. You become C++. You understand it. The biggest thing I see Java programmers struggle with is that in Java, unless it's a primitive, which none of your objects are, they're all sort of reference types. You do new, whatever, right? The problem is that syntax is equally valid in C++. You can do that. The difference is that C++ is not garbage collected. Now you're leaking objects everywhere. You're going to run out of memory. And getting Java programmers to get their head around the fact that actually, if I want to make this new object, I just declare the object. It's not like a pointer, it's just an object usable straight away. And then understanding like lifetimes as well. In C++, something begins its life where you declared it, and it ends its life when it goes out of scope. In Java, it's just it begins life, and at some point it's going to disappear. I don't need to worry about it. In C++, you very much do need to worry about it. So that's part of why I say not Java.
Yeah, I think I'm
What do you think of C then?
Sorry?
What do you think of C?
I use it when I have to.
So have you checked out this
very
stuff
much do.
on your
You can write much better code in C++.
C++ is, how much bigger is it? The scoping spectrum?
In terms of the language feature set, it's much bigger because it encompasses what C gives you.
Okay.
Yeah.
There's one or two C
So normally
features
you use
C++
C
doesn't have
It'll take a while.
relatively minor, like declaring an instance of a struct and then explicitly naming the fields. You can't do that right now in C++. So that's actually being added. But in terms of like we have classes, we've got templates, template meta programming is an entire subject all in and of itself. We're talking about running functions at compile time, generating some kind of output from that, some kind of code, and then having that go into final program. Even template meta programming in C++ is Turing complete. People are Turing complete. So there's literally people who've written games. They've written games in template meta programming, and you get the next state of the game by recompiling the program. Like it generates you have source code that compiles into a program that generates more source code and some output. So no, it has vastly more complexity, but it's optional. If you don't have to use templates. you don't have to use classes if you don't want to. So whilst yes, it has got a massive amount of features, it's a multi-paradigm language, you're not forcing you to use it.
Give me a shout if you need some
It's interesting, isn't it?
Yeah.
advice for where to start.
Like almost infinity.
I mean,
If memory's not a question.
there's lots of really good features, and then there's lots of terrible ones that should be sort of avoided. But they're mostly inherited from C, to be honest.
Right.
A good example of this was the fact that I have a function that returns an int, right? But in my function, I forget to type return some value. 3. Yeah, return 3. Or whatever value I calculate, whatever it is. That will compile. That's allowed.
Well, I mean, to be fair, JavaScript is much newer and it has all these sort of crazy things about
Yeah, but
what's equal to what.
JavaScript's different now.
Well, it's literally JavaScript. Because I go around, especially school mums and women, involved in all that sort of stuff. The beauty of JavaScript is you can actually you can introduce something like this to someone in 10 minutes, really. WP.schools, I don't know if you've seen it, the little library example, and it's it can sort of switch someone on actually in a whole new world, which unfortunately, the one thing I find quite hard is the fact that around West Hampstead and Hampstead, there's lots of schools, 27 private schools or something, and state schools or whatever. Kids aren't really, they're touching on scratch, but kids in good private schools or good grammar schools they're leaving school without having any knowledge of coding, which is really silly. I went to Machine Vision conference, and I think Estonia's number 1, and we're like number 30 or something, or 31 in the league tables, and I think it's quite crucial really to engage people in this. I mean,
yeah, it is. I thought the Raspberry Pi was supposed to be making it sort of better, right? The idea was that
we've got trained people in schools.
And that I think is really the problem. People who can code probably have other things to do than teaching primary and middle schools. Well, I say primary, but middle and high schools, I'm sure.
And affordability, like mini robots and stuff like that, So, I mean, maybe things are changing, and I'm not aware of that because I'm not in the field. I was thinking about doing mini robots for schools and stuff at one point.
It's funny, really, because I'm really showing my age here. We had BBC B micros when I was at school, these sort of beige big things. Yeah. And I remember I would have been 9 years old, and we were running this program called Logo, and the idea was you had this little sort of mouse, and you gave it commands to run around the screen. Yeah. So you say, go left 3 squares and down, and you could use it to draw lines on the screen. And so you type left 3, enter, and it did. And everyone, okay, that, and then the teacher showed us how we could write these a list of instructions, so that you'd write this list, and it would have all the instructions in, and then later on you'd execute, you'd tell it to do this list of instructions. So, okay, that's great. And it didn't really occur to us that what we were learning programming. Right? Because this list of instructions, that's a function, right? And then you're defining the function. You're not doing it now. You're, calling it later. And we got it to write, well, probably not Hello World, probably like Hello Miss or whatever it was, but
it must have played a major part. Now.
Oh, maybe eventually it led to me sitting here. I mean, but yeah, it's funny. It was just kind of fun to us at the time. It's a lot more interesting than maths or spelling. But
that's another thing, isn't it, about the maths? I mean, they're trying to raise the game, but then, from what I've seen from my daughter's work, the teachers got the maths wrong. She's, and then she I don't know. It's all a bit crazy. But, what can you do? I mean, you can write to the Department of Education.
Yeah.
But what else can you do? But then I'm just hoping I'm wrong, and that there is stuff feeding through the system, filtering through the system slowly. That I'm just not aware of.
I mean, I don't know if programming, if state schools are getting better or not. I mean, I think certainly what is becoming more prevalent is that there's just industry certifications, industry programs, community programs, sort of free stuff that's sort of out there, right? If you know how to use Google, have an internet connection, that kind of thing. I think in terms of this structurally managed learning, I'm not so sure that that's necessarily there. But I think.
But do we need it though? Because my argument is I think we do, but I'm not working with the open source.
I think part of the issue is if the state system was to say, well, we obviously can't teach people everything. One of the key skills you then need is the ability to teach yourself.
Yeah.
It's great. It's great if you're someone who can just teach themselves. Like, all of my coding experience is purely been from teaching myself. But I think it's partly about motivation. So
Would that meet the needs of the economy in say 8 years, 7 years time?
Well,
so that's a question, isn't it?
I guess the argument is just teaching people maths to GCSE. Having a maths GCSE is not going to make you an engineer or a physicist or whatever. But a certain percentage of people will go, oh, well, I like that, I'm pretty good at it. And they'll continue and they'll do an A-level, and then they'll go and do an engineering degree or a physics degree or a maths degree. And that's how we build those skills. Whereas if you stopped teaching the maths at plus and minus and maybe multiplication, then they'd never sort of get on to going trigonometry. Oh, that's kind of interesting, for example. So the idea, and I think it's a good one, is that you don't necessarily have to have people leaving school at 16 able to go straight into a programming job, but just having a basic idea. A certain percentage of those people who are introduced to it in school will go, hey, this stuff's really cool. And then, maybe they'll sit at home and write Python or whatever.
Self-teaching again.
Yeah. Or go on to do a computer science degree, software engineering, whatever it may be.
And then the thing about that is, once you're into the early extended education, obviously at the university level, there's an inherent cost to that as well.
£9 grand a year is
at least 9 now. I think it's 95. Yeah, but this isn't a country where that's provided for free, and so there's an inherent barrier to entry there. Having if you're someone who is able to teach themselves, they know what they like, then you're sort of at least in the programming world, where we're fortunately not in a sort of heavily licensed situation, because realistically, if this was, I really fancy being a doctor or a surgeon. That's just, could you imagine if it was? I mean, the real problem is, it's one of these, programming is one of these industries where it's largely, depending on what you're doing, harmless. It's not always true. There's a device called the Ferrac 25. Do you ever hear about this? So it was for radiotherapy, and it's a damning tale of incompetence, really. So the previous model had a bunch of hardware safety switches in it, and the firmware was written in C. And then on the 25, they decided they could save a load of money. We'll just strip off all this safety hardware and put it in software. Sadly, the software was lacking a lot. It was copy pasted from the previous, and it killed people. It actually killed people. It gave people lethal radiation doses, and it would only happen if the operator of the machine had navigated the menu in a certain way. And it was eventually nailed down. Obviously, nobody went to jail over it. It was a terrible occurrence. But by and large, it's one of those.
Nobody went to jail for it.
Like,
No.
innocent mistake, right?
No, I've got friends who are doctors who tell me all sorts of things.
Yeah. But they're being a doctor, right? That is heavily licensed.
No, but I mean, they've got wards of people and something's gone wrong.
Yeah.
I think, that's a bit heavy, isn't it? No one doesn't want to change their career or whatever.
Especially you have to accept the territory, really, for doing that kind of job. But again, doctors are not heavily licensed. But I think as well, to your point about the sort of the demand in the economy and where Britain's going, for Britain at least. I mean, we are very heavily a service economy already.
Yeah, I know.
London at least, there's a lot of tech jobs.
Yeah.
We are going in that direction. So I think at least for the nation, I think that's not a bad direction to send people in going into these kind of jobs, tech ones.
Because I was like looking at the sensor, just putting some ideas together, and it's out now. It came out like 2 months ago, and it's based on LiDAR and lasers and sort of machine vision, looking at in-depth vision, and previously we've been using GPS to do the mapping of, you know, these mobile robots that deliver your Tesco shopping or whatever. But they'd actually decided they found a way to use the lasers, which I was just looking from an engineering perspective, you know, rotating the laser and seeing if we can find a density differential or something like that, you know, just something, or even cluster recognition, you know, instead of facial recognition, you know, it's stuff that we do. Anyway, it's out, 75,000, but when I was talking to companies in the UK, they were saying, oh, you know, we're just go-betweens, you know, all the stuff's being done in Germany or whatever. And I thought it's just really sad, because people say you can't, I don't know if that's entirely true, but it's very difficult to manufacture anything over here because of the service side of things, which, so I thought coding is useful, but you need an API, don't you, for most gadgets anyway, you know. And I was trying to do JavaScript, but that's, again, that's for something that's quite small in 9 volts, but if you're going for anything larger, then it's good to just broaden your horizons in terms of coding, isn't it?
Yeah, I mean, especially for embedded C++, is highly used. I mean, at the end of the day, when you think of an API, right, everything is going to be an API. It just depends what an API means. If you're dealing directly with the chip, its API might just be some instruction set it offers, which generally you would aim to abstract away. You know, the API of, say, Intel CPU is x86 assembler, but you write C++, someone made a compiler that translates that to do that. If you're an electrical engineer, then your API is the physical electrical signals on the pins, right, the pin outs. So, I think everything has an API, needs to have an API at some level in order to interact with it. Even kind of engineering, really.
What's Arduino based on then? Because Arduino is that a language itself as well? Or?
Arduino, no, it's a brand.
It's a brand, isn't it? So like those switches or whatever. But,
yeah.
But the API itself is written in what though? Or it can be written in anything.
They're not really an API, they're chips.
So the electronic thing that you just mentioned.
Yeah, it's a processor. So I believe most of them are ARM based. They run the ARM instructions, just like your phone probably does. Like most phones are ARM. There might be some that have MIPS instructions. I'm not sure on that. But at the end of the day, it's just like it's the same model as what your PC does if you want to run Linux or Windows or Mac on it, right? So Linux is obviously like the primary candidate. But it's got its own. The chip has its own instruction set. You have some compiler for that. You don't write an OS in that language. So I think you can run like embedded Linux on Arduino.
Yeah.
I think some of the more expensive ones actually have a MMU, memory management unit, and then you can run proper Linux on it. Possibly even Windows RT. Actually.
But again, there's not much competition with Arduino. I mean, Raspberry Pi is quite interesting, but Arduino, some of the units are like £99, or you know, it's, and that's not to a lot, you know, people.
I mean, what it is at the end of the day is someone has obviously taken off the shelf, what are basically off the shelf CPU chips, right? Off the shelf RAM. Someone's designed a circuit board for them. Just run them off. They just run on. There's nothing particularly bespoke in an Arduino, right? The hardware is all the same for the Raspberry Pi though. They've arranged off the shelf components into a little board.
Affordability is quite different though, isn't it?
The what?
The affordability is quite different though, isn't it?
Yeah,
between Raspberry
Pi. Yeah,
and I think it should be the national curriculum, to be quite honest.
Yes, it should.
And it's not, you know, that could be done, you know, between a group of kids. You know, but anyway, I've got a friend who's written some stuff for robotics, and he works in schools as a way. I'll have a little chat with him. Just, I don't know. I think it's because I'm a mum, maybe.
No, I totally agree with you. I think it would be great to get more kids into programming. You know, it is a good career track. I think the caveat is finding the teachers who want to program it and or can program it. You know, I think part of the sort of Raspberry Pi sort of falling short was the fact that okay, you can sort of sling a load of these at schools and whatever, but who's actually going to sit down in the classroom and show the kids how to use them? I don't know. Part of me sort of thinks maybe the answer can be YouTube videos, right? There's tons of YouTube videos online tell you how to do blah blah blah.
I know. I've never got around to. Never found time to watch them. Basically.
And the thing is, it's not just about that, right? You could get a kid in front of you, give him an Arduino, maybe he's really excited and wants to play with it.
Yeah.
But then the moment it all falls apart is when he's having a problem. Can't answer screen questions.
But the other thing that's why I'm finding quite upsetting is that if my daughter makes mistakes, she's getting detention. This is primary school, so I learn from mistakes. I learn everything, physics and everything from.
Yeah.
You know, so I can move quite quickly from that. Obviously, you need to take the risk, don't you? And
That's that. I mean,
and so they're getting in trouble, and so I just think I need to write to either Ofsted or someone. I just find the whole thing shocking because, and maybe the teachers are finding the change in curriculum. The goalposts are changing so quickly year by year. That they're, you know, if they've got C in GCSE maths and just scrape through, then
I mean, I think kids being given punishments, but if it's for their behaviour, the child has behaved wrongly, then a punishment like a detention makes sense.
Yeah, if you haven't done your homework, but if you've done it and you've got it wrong, that's what it is.
Simply incorrect. That's I mean, psychologically, that's a terrible thing.
Yeah, absolutely.
So my daughter got accused of cheating, and so for 2 weeks she was really sad. And she said, "Mummy, I want to go back to Camden Council or whatever, you know." And she showed me a maths assessment, which looks like a GCSE paper, just like 10. And some of the questions they've marked wrong or right. So I thought, oh no. This is
Oh dear.
it's all a bit naughty, isn't it?
Okay.
How big problem is it?
So that's
5
that's
minutes
there,
before we get on the
that's off
ceremonies
here,
you get out.
and then the colon.
I really found this
and
exercise.
these are in curly brackets.
Those are fine. These ones are here.
Well, I'll try and make an effort for September. So,
we've
can
been
I
through
bring my
so many
daughter,
different
or is
ways
that,
of doing
she's on
this.
the iPad
I
with
get
it,
mixed
is
up
that
between the
problem?
two.
I mean, as long as she's not disrupting the class.
Yeah, and if she does, then I'll just have to leave, and that's that.
There's
Isn't
so
it?
many different ways.
But there's no rule for the licensing or anything
Oh,
here.
Still confused
this
with member initial.
premises, I don't know. I don't think
Sometimes
it's
it's
Yeah,
8
I'm not-
o'clock,
okay, calm down.
like a pub or something. Some
How
rooms
does
are
the
9
toilet
o'clock,
last?
but
yeah. I'd ask on the
No,
desk, they'll know.
upstairs they said it's not a problem.
Then it's not a problem.
So did anybody finish?
Right, I'm gonna go.
The
Thank you.
exercises?
Yeah.
Yes. Did anybody finish the exercises? Put your hand up. Yeah. One person. Right. So one person has no homework this week. Everybody else does.
And we will be expecting them filled in and handed in by next week, right?
Yeah, and so next week I will go through the solutions to the exercise. So I don't know about marked and handed in, but
I mean,
we can have a look through people's if they're in your public repositories.
I think we'll put it this way: is that if you really don't feel you need to do the homework, then don't. But I would base whether or not you need to on how well you did in our test last week. So if you did amazing, then clearly you're on the right track. If you didn't, then it's probably worth doing.
Yeah. So that nearly worked, didn't it? Yes, it did work. Next time we'll be talking about inheritance, and we'll probably talk a bit about virtual functions, or I might change that to talk about a bit about smart pointers. I don't know how I'm feeling yet. We'll definitely talk about inheritance though. And 2.5 minutes early, unusually. We usually overrun, but that's all I've got for you this week. So thank you all for coming, and I hope to see you on Tuesday.
So thanks very much for coming. As you know, we are going now to the pub, Beer Schenker, so you're very welcome to join. And
Just around the corner.
yes, and buy these two guys a pint to, as a thank you. So join us.
I'll give you the link.
So I've got to change those back. Use the first name.
11 beneath.